This is number 32 in chapter 4. It's looking at reaction stoichiometry. So now we have reactions, and now we can relate one compound in a reaction to another compound in a reaction. And the question reads that we have sulfuric acid dissolves aluminum metal according to the following reaction. And so here's how sulfuric acid dissolves solid aluminum metal according to the question. So there is our chemical equation. We have two aluminums reacting with sulfuric acid to give us aluminum sulfate and hydrogen gas. We need to make sure that our reaction is balanced, and we should have a 3 there. We have two aluminums, 3 sulfates, 3 sets of H2, and so this reaction is balanced. We need to have the reaction balanced so we can relate stoichiometry, which is the coefficient in front of each molecule that allows us to relate moles of one molecule to moles of another molecule at any point in time in the chemical reaction. And so it says we want to dissolve an aluminum block, and this aluminum block has a mass of 15.2 grams. And the question is asking us, what is the minimum mass of sulfuric acid to cause the aluminum to dissolve? And then the second part to this is, what mass of hydrogen would you produce? So you need a certain mass for H2SO4, and you're going to produce a certain mass with hydrogen. Both of these questions are answered in the same manner, meaning that we need to get moles first. We cannot relate mass of an element or a molecule to mass of a different element or a molecule. The reason being is these guys have different atomic molar masses. They also have different molecular molar masses. So the only way we can relate one to another, in this case relating aluminum to H2SO4, sulfuric acid, or relating it to hydrogen gas, H2, we have to figure out moles of aluminum. So let's begin there. We take our 15.2 grams. We go to our periodic table and we see aluminum has an atomic molar mass of 26.98 grams per mole. And so that allows us to determine how many moles of aluminum we actually have in that 15.2 gram block. So we have 0.5633 moles of aluminum. Now that we have that, we can relate it to the other molecules in question. First off, we'll look at sulfuric acid. And so if we have this many moles of aluminum, we need to relate that to moles of sulfuric acid. And so there, for every 2 moles of aluminum, there are 3 moles of sulfuric acid. I get that from the 2 to 3 stoichiometry in the chemical reaction. And that would put us in moles of sulfuric acid. And now we want to go from moles of sulfuric acid to grams of sulfuric acid. And for that we would have to determine its molecular mass, which I've determined to be 98.06. And so now we can get out of moles of sulfuric acid and get into grams of sulfuric acid and answer the first part of the question, which is we would need 82.86 grams of sulfuric acid And we need that in order to dissolve the 15.2 grams of aluminum. So that's the first part. Again, you have to get the moles first of the aluminum, and then once you're in moles, you can relate that moles of aluminum to any of the other molecules in the chemical reaction based on that balanced stoichiometry, those coefficients at the beginning of the elements or molecules. But we're not done yet. We still have to figure out how much hydrogen gas is actually produced, but the process is the same. We first start with our moles of aluminum. We then have to look at our reaction stoichiometry, and we see that we have 2 aluminums for every 3 hydrogens. And then we can use its molar mass for the hydrogen to convert that into grams. So the moles of aluminum canceled out, and then we have 2 grams of hydrogen for every mole of hydrogen. That gives us 1.689 grams of H2, and that would be produced. So that's how we do it. We relate everything to moles. Once we get to moles of aluminum, we can relate moles of aluminum to sulfuric acid or hydrogen gas, and then use their molecular masses to get them into grams.